Hello everyone, this tutorial is made for you to understand dynamic mathematics with trigonometric functions, how the graphs of the trigonometric functions help you to solve problems in calculus. That will come to know later, but right now I am going to draw the trigonometric graphs to mention their domain range, which will help you to study function as well as inverse trigonometric function in your syllabus. Obviously, this video is being made for class 12 students, but class 11 student also will be benefited. They can access some point from here. Here in this diagram, I have taken these folders, one for sine, then for cosine, then for tan, cot, sec, cosec, like this. All the graphs you can see in your book also. But here what I can do, in the same graph I can draw all together, I can compare, and I can tell you how to remember one trigonometric function if you know the other, provided the angles taken there complementary. Let us start first. For sin x, I am using this folder. See, sin x graph I have got. It is passing through the points minus pi, pi, 2 pi, 3 pi, 4 pi, like this. It is passing through 0 also, because you know sin x is equal to 0 when x equal to 0, pi, 2 pi, like this. And sin x graph, you can see that it is going from minus infinity to plus infinity. So domain of this function you can write as minus infinity to plus infinity. Range of the function will be minus 1 to plus 1. Remember, sin x function has domain minus infinity plus infinity and range is minus 1 to plus 1. It cannot take value larger than 1. It cannot take value smaller than minus 1. Okay. So its domain is minus infinity to infinity inside first bracket, range is minus 1 to plus 1. Let us go for next one, cosine x. But cosine x characteristic you can understand if you make this one off first. I make this thing off. So if I make sin x function, if I do it for cos x function, we can see that it is passing through the odd values, odd multiple of pi by 2, that is pi by 2, 3 pi by 2, 5 pi by 2 through these points, minus pi by 2. Why? Because cosine function, when you put x equal to pi by 2, value is equal to 0, minus pi by 2, then also value 0. That's why the graph will be passing through these points. It also has maximum value plus 1, minimum value minus 1. Let us go for next one, that is for tan x. See, the tan x graph is passing through 0, pi, 2 pi, 3 pi, 4 pi, 6 pi, like this. And these are the points where the graph cannot be drawn. Later on we will mention that this as a point of discontinuity in continuity chapter. So tan x function will not be continuous at the point pi by 2, because the graph can never intersect this line x equal to pi by 2. This line is supposed to be the asymptote to this curve. It will meet the curve at infinity. Okay. It passes through pi, then there is another asymptote 3 pi by 2 here, 5 pi by 2 here. It's like this. Let us go for next function, cot x. For cot x graph is just opposite to that. Here it will pass through pi by 2, 3 pi by 2, but these are the asymptotes, but in along negative y-axis. X equal to pi, x equal to 2 pi, x equal to 3 pi, they will be meeting the graph assumed to be at infinity. So they are asymptotes for this graph. Asymptote here at this point will be x equal to pi by 2, this line. This is the graph of cot x. It cannot pass through origin because cot 0 is an undefined quantity. Then let us go for, I put this one off first. For sec x, the graph is like this. It is not very easy to remember, But once I draw the graph of cosine x with sec x, then you can remember easily. If anybody remember cosine x graph, he can remember the sec x graph also. Just I am doing cosine x graph on it. First I make this graph. I go for coloring of this graph. If I use this color, then this is the color for sec x. In the same graph I am going to draw cos x. Then see the nature of cos x here. So cos x, and if anybody remember cosine x graph that I did earlier, then sec x graph can be easily drawn. At the top it will go up, or at the top it will go down. It will go up at 0, go down at pi, go up at 2 pi, go down at 3 pi. You can remember this way. Whenever you forget to remember the sec x graph, you drew cos x and start plotting sec x this way, and these two lines will become asymptote. Okay, let me go for next one, that is so I am doing it for cosec x. The cosec x graph is like this. If we go for coloring of this object property, then coloring we can make it thick also, not required right now. This is the graph of cosec x. Sometimes myself also forget how to get cosec x without plotting all these things, how to get the shape here. But drawing is not possible without plotting the points here. So these are the points you always have to take. If you don't take, then rough sketch is possible, but that doesn't help to solve any problem. So this is the graph of cosec x. Any moment you forget to plot this graph, you plot sin x first. This is sin x. See, it's like cosine x. It will come at the peak. At this peak, it will open up. At this peak, it will go down. Alternately, either it's going down or going up. It happens this manner. If I make this one different color, the graph will be more prominent. This is the graph of sin x, and this is the graph of cosec x. This way, whenever you are able to draw sin x graph, this one, this maroon color sin x, cosec x will be started from its top. And here, cosec x, the domain except 0, pi, 2 pi, every point you can take, but range is minus infinity to plus infinity. It can take any value between minus infinity to plus infinity, but domain cannot be included the point x equal to 0 or pi. Okay. Now, after knowing the concept of the graphs of trigonometric function, we can plot the graph of sine of minus x, cosine of minus x, tan of minus x, all these things. Let us see. For sin x, the graph is this. If we plot sine of minus x, then I have to remove this first, which I am going to show you. Wait a minute, I think I can do it here only. Just I have to change this one. I go for sin x and there minus sin x. Yeah, this has come. So this is a reflection of the graph about x-axis. If sin x graph is there, sine of minus x graph can be obtained just by reflecting it about x-axis. This was the graph of sin x. This is the graph of minus sin x, the dotted one graph of minus sin x. So minus sin x is the reflection of sin x about x-axis. Now let us go for cosine x and minus cos x. If we do cos of minus x, graph will not change. Why it will not change? That I will explain in different class. But if we do it for minus cos x, then see again it's coming reflection. So if a function y equal to fx is there, y equal to minus fx will give its mirror image about x-axis. Go for tan x graph. See what happens. This is the tan x graph, minus tan x, just like this. Okay. This is also reflection. See, this part is reflected about x-axis. This part is reflected about x-axis. Actually, this is the graph. So when this part reflected, you will get this. This is the graph tan x. When this part reflected about x-axis, it will go there. Okay. So if fx graph is given, minus of fx will give you the reflection of the graph about x-axis. Please keep this in your mind. This will help you a lot in calculus to understand not only function, continuity, differentiability and application of derivatives. Now we go for cot x. Cot x graph is this. I just make this color pink, then minus cot x color I'm changing. Okay, so again you see this is the reflection of the cot x graph about the x-axis. This is cot x, its reflection about x-axis lies here. Similar is the case for other trigonometric functions. We can do it for sec x as well as minus sec x. If I make this one off, the same manner you do the graph of sec x. Put this one off first. Sec x graph is there as you have seen earlier, then minus sec x. Okay. Do you see the reflection here? This is the main graph, the thicker one. Reflection about x-axis comes this manner. Reflection about x-axis coming this manner. So this is the concept of reflection of a graph about x-axis. When you take the mirror image about x-axis, the graph becomes, if it was for fx, it will be for minus of fx. Let us go for last one then. This is for cosec x and this one going to be for minus. Again the same manner, cosec x graph main curve is there, its reflection about, and it is written here, you must have seen cx means cosec x minus cosec x. If this one cosec x, its reflection about x-axis will be like this. And one thing I'd like to tell you, which I told you earlier, if you want to practice all these on your own, you must download GeoGebra Classic 5 app in your computer and then you can do it yourself. If you have time, you are finishing your work, I think all the work given that 15 page or 16 page work have given matrix determinant, you are doing that. Whenever you are free, you can practice these sums, you can enjoy. This is another example of dynamic mathematics where we can draw whatever required at any moment, even from the graph of sin x. Next video I will show you from the graph of sin x how to get the graph of sin 2x, graph of sin 3x. I mean transformation of graph will come automatically, but before that I would like to make a video where there will be the concept of exponential function, logarithmic function, and like 2 to the power x, 3 to the power x, or y equal to log x, domain and range of those functions I am going to explain. So you just wait, I'll do it, I'll send it in the group as early as possible. Thank you for watching.